Good morning, everyone. How are you all going this morning? I agree with that, Luke. Yeah, I've never been one to really celebrate the end of the week, but at the moment, it's nice to get to the weekend, isn't it? All right. So the plan for today is we're going to go over some of the feedback from the first assignment. So the way it works is that I mark the assignments. A sample of the assignments are randomly selected and sent off uh, to another lecturer, Latrobe, to moderate. I then receive feedback from that moderation, which I share with you guys. And the aim, firstly, is that I improve as a marker and become more consistent. And secondly, that you guys get really high quality feedback so that your assignments improve over time. And so let's go through some of that feedback now. Yeah, can you all hear me okay, firstly? Great, thanks, Rebecca. Okay, so the first bit of feedback, which is really, really important, actually relates just to the way that you convey information at university level. So I can't stress enough the importance of getting on board with this really early in your university life, because there's the entire university system virtually globally is geared towards highly reproducible report writing and science. And if you can fall in with that really early, then you can get a lot of marks. But not only that, you stand the potential to actually contribute to that field of knowledge as well. So part of that is the Harvard referencing system. And so if you understand what that referencing system is and apply it really early on, you just get a stack of marks for no real content. So for this assignment, for example, it was a sixth of the marks, and it means that you only need 40 marks out of 100 for your actual content, which is very, very attainable. So if you get this basic referencing sorted out, you'll sail through first year just on account of having to achieve a relatively low standard across everything else that you do. So yeah, the system is really geared towards drilling that in early, so I can't urge that enough. So some of the specifics of that are and there are a couple of students who were guilty of this, which is not the worst crime in the world, actually. They used more references than they actually cited in their reference section, but they just forgot to include those references. The next sounds quite pedantic, but again, it's just about effective scientific writing. That's to ensure that when you're conveying units and quantities, that you put a space in between the unit and the number. Next is a common mistake across all of the assignments, was that graphs and tables weren't correctly labelled or numbered. So they should be referred to in the order that they appear throughout the document. And the title of the graph or table should appear beneath it and refer to what's actually represented in that data. There was actually quite a huge range of other things that were picked up on, but I think I'm just sharing the main ones with you. And the last is that numerically list the references rather than using dot points. I hope you can all take that on board, because I promise it will make your life a little easier. Any questions on that? Have you all been able to access the assignments that the marked assignments that I've uploaded? Oh, sorry. Depending on if it's a graph or a table and so on. I mean, the main point on that, Erin, is that there's the institutes got really clear guidelines on where they go, depending on what's being represented. So yeah, I think it's just the main thing is to probably have that document open as you're working and making sure that as you're working that you're aligning what you're writing with it. Okay, so next, in terms of the feedback on the actual content of the assessment, which is probably what we should be really talking about, and the Shiraz wine really was just a very, very basic wine making style. So this is probably one of this is the most commonly made commercial wine in Australia. It's about very basic winemaking that protects the attributes of the fruit. So the criteria in terms of the fruit itself is we're looking for a bit of concentration in the wine. So what we want to see is a little bit of concentration in the fruit, and that's achieved by having harvest criteria that would have a small amount of shrivel in the fruit, not some squashiness or bagginess in the berries, and that being balanced out against the potential high downside risk of high alcohol. So when you're picking fruit to this particular target market, you're looking for that concentration, but without crazy high alcohol. So in terms of fruit selection, that's probably the main issue. Issues around tannin for Shiraz are not particularly relevant because the variety is not a highly tannic variety unless you make a real effort to extract those tannins, and that can be done through the primary method for boosting tannin level significantly would be to cold soak the fruit, or to include some stems in a crushed, destemmed fermentation, such that there was a greater amount of extractable tannin involved in the fermentation. But in general, the winemaking plan would revolve around appropriate fruit and then a very basic winemaking plan after that. So it wouldn't be necessary to do a whole bunch of fermentation or post-ferment maceration or highly extractive winemaking processes. The aim would be obtain the concentration from the fruit and then protect the primary fruit characters through a really truncated winemaking process. So we don't need to go 2, 3, 4 weeks on skins. It could be as short as 7 to 10 days, and preventing aroma loss through some temperature control is probably desirable. But beyond that, it's not a particularly complicated basic winemaking process. And what a lot of you did is come up with more detailed, elaborate versions of that, and there was no penalty for doing that. The main reason you got marks for making other suggestions and recommendations was when you justified that in terms of the objective and how that would help with the style. But the main feedback probably was many of you sought to probably extract more tannin than what was necessary. At least that's the way it came through. And yeah, so I hope you can take that feedback on board. But yeah, I mean, I think some of those wines, if they were made, they'd be really interesting. Okay, next to the Sauvignon Blanc. Now, again, the key criteria for this style was flavour markers that were sort of across the slightly underripe to ripe spectrum. So fresh commercial Sauvignon Blanc is not generally ripe and tropical. And the reason for that being is a lot of the time when the alcohols that correspond with that, the wines tend to go sweaty in bottle and they lose all that primary fruit character. So if you look at any descriptor of commercial Sauvignon Blanc in the market, it's always gooseberry and aromas at the low end of ripeness rather than at the high end of ripeness. And then in terms of the palate of those wines, they're generally fresh and clean and, potentially on the simple side, but it's that cleanness and freshness that underpins the style. So the processing should really reflect that. And to achieve those aroma compounds where the pulp has got no flavour but the skins do, soaking the fruit might be necessary, or even soaking fruit with enzyme, or potentially enzyme at crushing to stemming could also work. So the idea is identify where those flavours are. If they're already in the juice, then great, you can proceed with crushing to stemming. And if they're not, consider a small flavour extractive process before pressing. And most of you had recommendations along those lines, and I think you would have achieved the desired wine style. The next point to make is that because the wines are low in alcohol and high in freshness, they're relatively delicate. So any phenolic extraction or any oak input will result in phenolic compounds or other characters that will have a reasonably prominent effect on the wine. So it's for that reason that to achieve this style, like with the Shiraz, again, it's about relatively basic and controlled winemaking, rather than doing too many complicated things. And again, marks were allocated for the quality of the argument around the choices made, rather than for the choices made themselves. Okay, any questions? Okay, let's move on now to a recap of the subject. So we're coming now into writing up the final assignment and getting ready for exams. So I guess what I want to make sure is that each of the lectures that we've had, that you've all understood the main focus of each of those lectures. And so we'll go through now the key slides from those lectures. This is I guess in many ways, this is your last opportunity to really clarify your knowledge with me before we go into that sort of heavy assessment period. So please take the time to ask questions if you need to. So number one, going back to our very sensory assessment lecture, the main point of this lecture and this topic was to stress the importance of the deepest possible understanding and connection of the raw ingredient. And we developed the idea of a very sensory assessment. I should also point out that procedure now is approaching 20 years old. So it can probably be substantially refined, and it probably is substantially refined in industry where winemakers are looking at fruit. They've refined this strategy, and I think to some extent you can see pretty easily where it needs to be refined. So if you can recall the great difficulty we had in assessing accurately how much and how easily the juice came out of the pulp. I mean, I think we could approximate that in a quicker and much less messy way with methods that you might find to be more suitable with the fruit that you're working with. And I'm sure there's a lot of that going on. And I guess the other thing that this methodology stressed was a pairing of sensory derived data with pH, Beaumet and TA, and then using that as one data pool to make decisions around harvest and the appropriateness of wine for particular wine styles. Any questions on very sensory analysis? Okay, so in some ways this could have been the first slide, just looking at the rationale for going through that process. So the inadequacy of pH, TA and Beaumet as a parameter on its own. So I think we touched on in this lecture the historical use of Beaumet to set grape prices across. Well, it was a global trend, and the pitfalls that led to were the pursuit of sugar and in and less focus on flavour and balance. So now there's certainly a greater focus on composition rather than Beaumet. Next thing is to be able to use this in. So next thing is I think hopefully we've all got a good understanding now of the information that we need to collect. The next question then is, okay, what do we do with that information? And that's, in the first instance, it's planning for any shortfall or abundance in those parameters, which might be a really require quite a detailed plan where you've got a range of shortfalls or abundances. But for the most part, it might simply mean the procurement of the right quantity of tartaric acid, or alternately, especially these days with many high Beaumet vintages, the adding of water to must early on in the fermentation. They're the two basic sort of responses anyway. The other things that we have to do with that information are a little bit more complex, and that's understanding the appropriateness of the fruit for the intended wine style. That's a really difficult thing to do because I think when you see fruit on a vine, you have quite a whole picture. You can see how healthy the vine is. You can look at the soil and get some sense for the stress that plant might have experienced. But when you're looking at grapes in a bin, grapes in a bin largely without any analytical parameters look like any other grape in any other bin. It's very, very difficult to understand the appropriateness of fruit just that's parked in a bin. So it's that other information that really makes that possible. Okay. Any questions at this stage? Okay, so what we dealt with early in that lecture was looking at how we might immediately respond in terms of that vintage and that winemaking journey that we were on. But the other things that we need to do is also make longer term changes to what we're doing based on that information. So every bin of fruit contains in it, the vineyard management practices of the past, and it's an opportunity to appraise those practices. So what things worked well, what didn't, and if we build up that data pool over time, we're then in a situation where we can, truly reflect on what's happened in the past. And the last thing to do, which is something we always try and do across science, is share that information. So we've collected some information, and when we share it and discuss it, that's when the real benefit of that process comes through. Okay, so that's the summary of the berry sensory assessment lecture, which was I think 11 long weeks ago now. Next, we quickly going over OH&S. So going through an OH&S plan, which most workplaces now would have to have some broad policy about how particular things are handled in a safe way. So a clear statement of who has responsibilities for what, identifying hazards, eliminating or managing them, a plan for training, a plan for developing procedures that respond to changes in the work environment, a schedule of inspections or maintenance events, and documentation that relates to all of those steps and processes. So again, as winemakers, or at the very least as professional people in the workplace, you'll have higher end responsibilities for these plans, and therefore the maintenance of and editing and ongoing management of these plans will be potentially your responsibility. Okay. Next, so heading towards fermentation now. We talked about yeast and its importance in the winemaking process. So we start off with sugar and we end up with alcohol and CO2, and the bioreactor responsible for that is yeast. The way that we manage this process really defines a big part of the resulting wine. So to what extent have we managed heat? To what extent have we managed oxygen contact? To what extent have we managed nutrition are all inputs in the way we manage yeast. I thought this slide was a pretty good summary as well, because it shows our increase in yeast biomass very early on. It shows our decrease in sugar. It shows our yeast cell mass, which is a potential resource for later on in the winemaking process. And hopefully this graph gives you an idea of some of the parameters that you're trying to steer when you're managing a fermentation. Next, just wanting to define some of the characteristics of a good of a good fermentation. So we're after the even and complete conversion of sugar to alcohol. So some of the limitations of natural fermentation, or some of the limitations of particular isolates, are incomplete conversion. This might be to do with nutritional limitations of strains. For example, there are some very highly aromatic producing yeasts that make incredibly perfumed and beautiful wines, but they're highly limited in terms of nutrition. So it comes back to that idea of what can our fruit successfully, what sort of yeast is best suited to our fruit. Freedom from off aromas is another big factor as well. Again, going to natural yeast, that we've got this incredible textural advantage we can obtain from those natural yeasts, but we've got all these downside risks from acetic acid and ethyl acetate production. So how can we manage those in relation to other positive yeast characteristics, for example? The last 2 points, probably good settling after fermentation, certainly less consequential, and reduction in the initial concentration of SO2 is probably a very minor point as well, because we don't have high levels of SO2 production by wine yeast. Then I think before I get on to SO2, we had a couple of weeks where we did on the whiteboard discussions of skin contact and non-skin contact winemaking processes and the advantages and disadvantages of each. I guess one thing that came through in some of the assignments is that there are still some students that weren't 100% clear on what differentiates a white winemaking plan from a red winemaking plan, at least in a traditional context. And that is to do with the time on skins. So for really clean, low phenolic, pretty aromatic wine styles, we're always looking to get the juice out of the berries, in a very quick and efficient way. And then at the opposite end of the spectrum, where we're looking for lots of tannin and lots of colour, there our skin, that's where our management of wine on skins is the essential part of the winemaking process. So I think one thing you've got to make sure that you're really clear on going into the exams is, what wines and varieties and styles need to be on skins and what don't, and what's the time frame for making a decision around pressing. Okay, now moving on to SO2 and the rationale for SO2 use. So to start off with, early on in the winemaking process, the main rationale for use is the ability for SO2 to bind dissolved oxygen and to inhibit enzyme enzymatic processes, which is a different rationale. We'll go through the chemical ones first. So other points to make is that SO2 has a very strong solvent potential, and polyphenolic compounds and anthocyanins can be dissolved. And the main point to remember from all of this is that the bleaching effect that SO2 has on anthocyanins is reversible. So as that SO2 level declines, those anthocyanins then become available again to express wine colour. The final chemical rationale is the improvement in taste that takes place when acetaldehyde is reacted with SO2. So acetaldehyde is formed either by the oxidation of ethanol. So it has that bruised appley sort of taste, sometimes described as nutty, and it's not preferred by consumers. And not only that, it over time, if that character is allowed to persist in wine, it becomes quite a dominant character as well. So going into some of the biological rationales for use. So again, early on in the winemaking process, inhibiting enzyme action that would result in extraction from skin. So where we might want to extract from the skins, there then becomes a tension between use of SO2 for antioxidative action and the need to have enzyme activity. And it's always that, I guess it's an ever-present tension in the winemaking process as you have competing objectives. The antibacterial rationale is quite important because lactic acid bacteria can quickly establish in a low SO2 warm, high oxygen environment, and where there's no plan to exclude that bacteria, it's possible to end up with levels of acetic acid 0.8 or 0.9 in a fermentation as a matter of course. So in general, winemakers seek to limit the impact of bacteria early on in the winemaking process with either a huge focus on exclusion of oxygen and the use of SO2 or the use of SO2. So, okay, moving on. Anti-yeast. Again, the SO2 can be used to inhibit fermentation and kill wild yeast as well. So SO2 added early on at reception stage can reduce the likelihood of spontaneous fermentation. So next, I think it's very important for you to become familiar with this table because it expresses very, very well the impact of pH on the efficacy of SO2. So we can see at a pH of 3, we need 14 milligrams per litre free SO2 to have a microbially effective level. And then at a pH of 4, we need 125. So it's a massive difference in the quantity of SO2 required. And the main point to reiterate with this graph and its use is that once we get over, say, levels of 45 to 55, the levels of SO2 become too high to allow in wine. And after probably 50 milligrams per litre, it's possible that asthmatics would react and there'd be pushback from consumers relating to the high level of SO2, complaints about headaches and those sorts of things. So we would generally not want to be over 50 milligrams per litre free SO2. And it's for that reason there that once you've got to the point where you're adding, where you've got a free of, say, 50, the next remedy really then becomes looking at the pH and saying, okay, can we bring about a more stable situation by addressing the high pH of the wine? The other strategy also, of course, is to know very early on in the winemaking process that the pH of the wine is going to be high and manage risk of microbial spoilage through high levels of high hygiene and exclusion of oxygen throughout the winemaking process, such that the population of spoilage yeast and bacteria is very low. So that's what we do with the information in the table in front of us. I'm just going to have a drink. This table that we have in front of us now is really useful because it gives us an idea of the desired sugar and acidity levels for particular wine styles. It shows, for example, that where we have a sparkling wine, which is traditionally low BOMA, certainly lower than 12, we generally have much higher levels of titratable acidity. So we might, if we have 11, a TA of 11, that might correspond with a pH of, with a BOMA of 11. And at the other end of the spectrum, we can have a full-bodied red wine where we might have, 14 to 15 BOMA, but we might have only 4 or 5 grams per litre acidity. And so in between those two represent, the sort of the majority of the world's wines. And it's I guess getting a feel for a subtle change in BOMA and a subtle change in acidity, it's potential for one vineyard to make a whole series of very, very interesting wines at different, balanced at different points, and understanding where those balance points are, I guess, is the fun stuff. Any questions? Actually, before I get on with instabilities, I probably have these slides around the wrong way. So next, malolactic fermentation. Malolactic fermentation, it's important, again, to stress, because there were some students who were unclear as to whether malolactic fermentation was desirable or not in the Sauvignon Blanc. So malolactic fermentation gives us the ability to achieve a microbially stable wine in a situation where we would otherwise go to bottle with the risk of spoilage. So that relates to red wines in particular, where the level of SO2 cannot be retained at a high level, firstly because generally the pHs are much higher, and secondly because of the high quantity of compounds in red wine that will bind SO2 over time. And as that occurs, the level of free SO2 would go down, and then the risk of malolactic fermentation taking place in bottle increases. So malolactic fermentation is a necessary process in the majority of commercial red wines, and is a optional process in the majority of white wines. Its sensory impact, where it's optional, to lower the acidity, to in changing from malic acid to lactic acid, where it's sort of changing from a fresher, aptly sort of character, if you like, being a malic, to a more complex, creamy lactic character. And that works for a large number of wine styles, but it doesn't work for every wine style. And an example of a wine style where it's probably not going to be effective is where we're looking at making a fruit-forward Sauvignon Blanc. So malolactic fermentation for that wine probably wouldn't have been a great idea. Okay, so in terms of the management of malolactic fermentation, so again, we're monitoring the decline of malic acid simply because we don't know where the end point is in terms of production of lactic acid. So we're monitoring malic acid going from wherever it might be, 1 gram per litre or whatever, down to 0, not the movement of lactic acid up. In terms of sensory observation of the process, we can see CO2 being evolved. We can note a distinctly microbial taste during this fermentation. We can note a cloudy wine at this stage. So there's a lot of physical indicators that the process is taking place. The last point to make in terms of this process is as we're shedding acidity during this process, it means, of course, our pH is changing and going up. So it's a really useful tool for deacidification. But potentially for many wine styles and most red wines is it's a process that ultimately takes the pH from, probably a tolerably high level to an intolerably high level in a lot of situations. So it's for that reason there that winemakers would intervene to adjust acidity very, very early on in the winemaking process rather than doing that during malolactic fermentation. So we find where we suddenly change the lactic acid, the LAB environment during LAB fermentation, that causes an attenuation of the fermentation process. So we know at receival that the pH is relatively high. We know that at reception that the pH is going to get higher still during malolactic fermentation. So we try and make that adjustment as early as possible and get all the positive benefits of that adjustment early, rather than having to make that adjustment during malolactic fermentation and risking the process running for longer. The reason that we don't want to take that risk in general is that our wine is unprotected during malolactic fermentation. So if we attenuate that fermentation, we run the risk of giving spoilage, yeast and bacteria an opportunity to establish a population in the wine. I think I've covered most of these sensory changes that take place. The production of diacetyl, which I've referenced a couple of times, there's lots of work going on that, because winemakers are becoming increasingly conscious that whilst it's a desirable characteristic in low quantities, in high quantities, or in fermentations that express themselves in a particular way, the compound can come across as overly buttery and simple and reduce the complexity of wine rather than enhancing it. So in terms of further study, there's lots of research now on optimizing LAB during malolactic fermentation. So, okay, any questions? So now, going back now to chemical instability. So having successfully got our wine through malolactic fermentation, or in the case of many white wines, primary fermentation, the next stage before we deal with chemical instabilities might be to bring about the best sensory balance that we can hope to achieve for that wine. So we would trial a number of processes or additions or approaches. So an example might be we might look at lees contact. We might look at lees contact with stirring. We might look at a series of rackings to make the wine removed off solids quite quickly. We might look at additions or inputs such as oak. We might look at removing compounds such as hydrogen sulfide through the use of copper sulfate. We might look at removing faults such as Brettanomyces related compounds 4EP and 4EG through membrane filtration processes. We might look at a whole stack of options through sensory trials to improve that wine, and having improved that wine to the point where we're happy with where it is from a sensory point of view, we would then look at bringing about chemical stability such that the wine was on the path then to be bottled. And so some of the instabilities we would plan to deal with would be tartrate instability, which we deal with through cold stabilization, protein instability, which we would deal with through bentonite addition and bentonite trials. Now, it's important to note at this point that the protein instability relates to white wine only, white wine and rosé, not red wine, whereas the tartrate instability relates to all wines. Phenolic instabilities and metal instabilities are also dealt with. The phenolic instability can be modelled in a number of ways. We can, for example, bottle a small sample of wines and monitor how those wines change in a range of environments, and then either conduct more advanced wine analysis or sensory analysis on those samples. We can remove phenolics that we deem to be in excess through fining agents. Polysaccharide instability probably relates more to the filterability of the wine, where we have complex sugar molecules that make filtration difficult. And again, they can be treated with enzyme additions, or even those wines being retained on the yeast lees and stirring, for example, would also assist with that instability. Okay, going back. Okay, so having dealt with having created a stable wine and a wine that meets our sensory criteria, the next stage is to consider the need for filtration. So the need for filtration should be assessed on the basis of who's drinking the wine and where are they drinking the wine. So where the wine would have an unknown customer, an unknown destination, winemakers generally assume the most prudent posture they can and ensure the wine goes to bottle sterile. And this would be best done by filtering the wine. And the best method of filtration in terms of achieving a low turbidity quickly is the use of cross-flow filtration. I chose this slide because it shows the traditional filtration method versus the cross-flow filtration method. And I guess this shows very, very well why cross-flow technology is becoming the preferred technology for filtration. Any questions? Okay. Hang on, is my microphone on? Hello? Yep, sorry. Okay, so next we've got our wine mostly prepared for bottling, and we talked about the anatomy of the bottling line, and we spent a little bit of time also talking about the composition of the wine going into bottling. So the sorts of things we need to be conscious of are what's the dissolved oxygen in our wine? What is the dissolved oxygen pickup likely from the bottling process? What's the level of SO2 required to offset, pardon me, to offset those levels? Then we think beyond the bottling process to the storage and consumer experience, and we think, what is the quantity of SO2 we need beyond the level we want for X number of months in storage? What is the level of SO2 that we need in the bottle such that when the customer opens the bottle, what proportion will be lost at that point, and so on. So we model back from, the last mouthful of the bottle being consumed by someone who's happy with what they're consuming to work out where our starting point should be. In terms of the bottling line itself, we went through the anatomy of the machine, mostly because it shows the various points in the process where winemakers can have input by way of gas usage, by way of moderating dissolved oxygen pickup. Okay, that's a summary of, I guess, the last 10 or 11 lectures. Are there any questions? Yeah, thanks, Luke. So um, the the uh, the strategy around addition of PMS. Let me just check my microphone again. Sorry. Yeah. So the strategy around the addition of PMS is we know that PMS is 57 uh, uh, percent SO2. So uh, we use 50% though for the calculation. So if our target is 15, we know that 50% of the compound is not SO2. So straight away we need to double that amount. But what happens is of the SO2 that we add, some go to free and some go to bound. So if we're going to add, if our target is 15, we know that half of what we add goes to bound. So that makes the amount we need to add immediately 30. And then we know that half of the compound that we're adding is not SO2. So that makes the amount that we would add 60. So that basic rule of thumb says that to achieve 15 milligrams per litre free, we need to add 60 milligrams per litre. Now, the limitation of that strategy is that the quantity of SO2 that goes to bound diminishes as any dissolved oxygen becomes bound. So if we have a wine with a very high level of dissolved oxygen, the SO2 we've added goes mostly to bound and very little of it goes to free. But if we have a wine that's very low in dissolved oxygen, the majority of the SO2 that's available to go to free goes to free and none to bound. So it's for that reason there that our strategy might be to use the multiply by 4 method for additions early on in the winemaking process, and then later on in the winemaking process, when we know that we have lower dissolved oxygen levels, we might break up that addition into 2. So we've calculated we need 60 milligrams per litre to achieve our total of 15. So we might start off, again, using 1 litre of wine as an example. We might start off and say, okay, well, our target is 15. I don't think the dissolved level is very high. Let's add 45 milligrams per litre of the 60, check our free again, and then make the last addition and try and land on the number you want with a lot more precision. What can happen if you don't do that is you might find that you especially with larger volumes of wine with very low dissolved oxygen levels, you might find that you're making over additions of SO2. So that rule of thumb of multiplying by 4 works for additions early on in the winemaking process. And when you use that same rule of thumb later, you just have to you use that rule of thumb over potentially 2 additions with a check in between. The other point to make on that rule of thumb, though, is how incredibly effective it is over a long period of time. Winemakers using PMS, are able to land on a target number with a little bit of practice. There's a higher degree of precision with that calculation. And I think it's just getting a feel for how much is going to be lost along the way. And, for example, aldehydes, you can taste if a wine has got some bruising in it, and you can straight away know, okay, so if the target is 15, I'm going to lose a much higher proportion of wine to bound because of those aldehydes. So instead of adding 60 milligrams per litre, I might make it 65, just because I know that the total SO2 is going to bump up a fair bit before it actually impacts on the free. And then equally, where that you've worked very well with excluding oxygen, where you've used heaps of CO2, where your vessel dimensions and seal management's been impeccable. Okay, you know what, to get to get there. We don't need 60. We probably get there with 55, and you'll find you'll be able to steer the process quite well. Okay, any more questions? So what we might look at for next week, for those that are interested, is we could do a little session on the major assignment. So if you're working, I think it's not due for another 2 weeks, but if you're interested, we can all log on next Friday, and I'll have whatever information that I have about that fruit as it came in that I can share with you all, and I guess as a group, if you share your reflections on your interaction with that fruit, and we have a discussion about that, it might assist you with your assignments. Yeah, look, I guess that question there is where winemaking is at the moment. So there's the long-term mark of the natural winemaking movement on the broader industry is going to be that where you're meticulous with hygiene and oxygen exclusion, and use other strategies to make good wine. How low can we go with the total use of SO2? And as it turns out, the answer is very, very low. I mean, I think the European sort of guideline for natural wines sits at a total SO2 level of about 50 milligrams per litre. But I've had a number of wines in recent years with 0 SO2 that have got a really high degree of freshness, a high degree of sort of fruit-forward, interesting characters, very low microbial impact on the wine. So my feeling is that it's possible to make virtually identical wine with very low or 0 SO2. The question, I think, for winemakers doing this is the cellaring and warehousing potential of that wine is different. So I think the strategy for those guys should be around making wine for a known. I mean, if you make wine with no SO2 and no established client base for that wine, you run the risk of having to warehouse that wine for a very long period of time and having an inventory that's spoiling before your eyes. And I think that's what we're seeing now is winemakers making very close relationships with supply channels and supplying low SO2 wines that a channel is asking for, and then that's working really well. But I think just to go out there on your own and make a natural wine with low SO2 is just so risky, because it could spoil before your eyes before you find a buyer. Okay. Look. I'm just on that topic. Look, I think it's a fascinating topic, and I think the wine industry is going to be vastly different in 20 years because of what's happening now in that space. I mean, I think there's some awful wines on the market right now. Where they will lead us is I think somewhere exciting. All right. If there's no more questions, let's leave it at that. If you've got any queries about your assignment feedback, I'll stick around and yeah, we can have a chat. But if not, please feel free to make contact during the week if you're having issues with your assignment, and I'll see you next week.